Good morning and welcome to my video. Today, I, Aryan Singh Rana, will be explaining you the solution to the lead code number 2971. Find the polygon with the largest parameter. It is of medium difficulty level and it is as well to today's streak question. So let's dive into the question right away. So the question says that you are given an array of positive integers num of length n. Okay, so it is simply saying is that the array integer is provided to us with nums as the name of the array and of length n. Now it is telling us about the definition of the polygon. A polygon is a closed plane figure that has at least three sides. The longest side of a polygon is smaller than the sum of its other sides. So it is simply saying as that this a polygon is what we call is what we call a figure which has three sides, and each are in a closed loop. And it is also saying that the sum of the two sides which are smaller than the third side is always greater than the third side, then it is known as the polygon. Or the basic concept is that if we take the largest side in a polygon and we compare it to compare it to the sum of the rest of the sides, then that sum should always be greater than the sum of the large sorry should be greater than the sum should be that sum should be greater than the largest side. Now if it is equal to the now if the largest side is equal to the sum of the rest of the sides, that it means that the that one of the side is of zero length, and it doesn't make it as a polygon. Now it is saying that conversely, if you have k which is equal greater than equal to three positive real numbers, which is a1, a2, a3 till a at k position, where a1 is greater than equal to a2, a2 is greater than equal to a3, and a3 is greater than equal to till so on till ak. So it means that the last element is either largest or equal to the second last element in the array. Now it is saying that a and a1 plus a2 till ak minus 1. So the second last so we are talking about the summation from first element till the second last element is greater than the last element, which is ak. Then there is always exists a polygon with k sides whose length is a1 till ak. Okay, so it is simply saying that it's the same thing that I just told you, that if the summation from the first element of for, or you can say the from the first side till a k minus one side, which represents the second last element in the array and the second last element, second last side in the polygon, the summation till that is till then is greater than the longest side, which is the ak. Then we can say that the polygon exists with sides a1 till ak. So it is saying as the perimeter of a polygon is the sum of all length of its sides. So it is simply now telling us this definition for the perimeter, which is that the perimeter is the summation of all the sides included inside a polygon. Or you can say the summation of all the sides which makes up to a polygon. Now it is saying us that the return the largest possible in parameter of a polygon whose side can be formed from now one or minus one if it is not possible to create a polygon. So it is simply saying us that we have been provided as it mentioned before, that we have been provided with the array nums, and it consists of length of different length of sides. Now it is saying us if we are able to make a polygon with the largest perimeter using those sides only, and we cannot repeat a side again and again. So if then we have to return the largest perimeter that we could find using those sides only. And if it is not possible to make a polygon using those sides available, the length of those sides which are available in the nums array, then we need to return minus one. Now let's dive into the example number one to get even more better understanding of the whole question. Now the example number one says that the input array consists of three sides, which is 5, 5, 5, and the largest parameter then, or you can say the polygon with the largest parameter we can make out of the nums array is of parameter 15. Now how is that? The explanation is also given over here. It says that it is only possible, the only possible polygon that can be made from the nums array is of three sides, which is 5, 5, 5. The parameter is 15. Now why? How did we judge or the this how did we check that it is possible to make a polygon of three sides with equal length 5? Now what we did over here, we first found out the largest side inside the nums array, which is 5. Now as we know that all the sides are is of length 5, so the largest length would automatically be any of the 5, so we take the last 5. and then we compare it with the summation of the rest of the sides that we did not consider. So the summation of the rest of the side would be 5 plus 5 is equal to 10, and 10 is always greater than 5. It means that we are able to make a polygon. So that is the base condition for it. Now coming to the second example, as you can see that the largest polygon, or you can say the polygon with the largest perimeter that we can make using the nums array is of 12. Now how did we arrive to that conclusion is that first we will find out the largest side and add the rest of the elements together. Now, what we will do, as I told you, first we find the largest side. Now, the largest side is 50 over here, and add the rest of the elements. Now, if we add the rest of the elements, the sum would be equal to 24. How? Now 12 is right over here. Now 1 plus 1 plus 2 is 4. Sorry, plus 2 is 4. 4 plus 5 is 11, and 11 plus 3 is 15. So the most that we can get is 12 over here. Now, as we can see that the 12 is less than the largest side, which is 50. So we cannot include 50 in our polygon. Now we go to the move to the second largest element, which is 12 over here. Now, if we check for the 12, now what we are getting the answer. If we add the rest of the element is 1 plus 1 plus 2 is 4. 4 plus 5 is 9, and 9 plus 3 is 12. So as you can see that the largest element and the summation of this rest of the sides is equal. So it means that one of the side would be of length 0, and it is not possible. So that's why again we cannot include the largest length that is available, second largest length which is available in the nums array, which is 12 in our case, inside the polygon. So we will remove 12 as well. Now we will move to the third largest side inside the nums array, which is, as we can see, 5. Now we add the rest of the elements except 12 and 50, because we have removed it from the from our equation. So what would be the sum of the rest of the elements except 12, 5, and 50 is 1 plus 1 plus 2 is 4, plus 3 is 7. And we know that the 5 is always smaller than the sum of the rest of the array, which is 7, which means that we can make the array, sorry, we can make a polygon using the elements 1, 1, 2, 5, and 3. And the number of sides over here is 1, 2, 3, 4, 5. So we can see that a polygon of length of sides with number of sides 5 is possible to make with the help of the nums array. So and the sum of the all sides would be 1 plus 1 plus 2 is 4, plus 5 is 9, and plus 3 is 12. So that's why the output is 12 over here. Now coming to the example number 3, as we can see that there are only 3 elements. So at most there would be only possibly one polygon that we can make, but we first need to check the main condition. If the largest side, the sum of the if the largest side is smaller than the sum of the rest of the sides. Now if we take a look, the in the current array the largest side is 50, and if we add the rest of the elements, the sum would be 5 plus 5 10, and it is always less than 50. So it means that we cannot make a polygon using the any of the using the elements inside present inside the nums array. That's why the output over here is -1. Now, coming to the solution that I have written over here. Now, let me just first tell you how I solved it. Now, what I did is that first I sorted the whole array. Now, why did I sorted the whole array? Let me tell you an example. One, three. Let's simply take the example from the example number 2 only. Now, as you can see that we have this as an example. Now, why did I sorted it? Because if I don't sort it, then it would be much harder for me to find the largest number, because then I need to iterate again and again to find the first largest, then the second largest, and the third largest, and then the loop needs to be ran multiple times to find the first largest. And if you want to find the second largest, then we need to ignore the first largest and run the loop again to find the second largest. If the second largest side is not, we cannot include that side as well, then we need to find the third largest. Then we need to iterate through the loop again to find the third largest and ignore the first and the second largest from that iteration. So that's how the number of iterations would keep on increasing. So that's why to ignore that, we first sort the array. So the sorted array would look like this: 1, 1, 2, 3, 5, 12, and 50. Now, with the help of this sorting, what we are able to achieve is that we know that the after the sort is done, the largest elements would always appear at the right side of the whole array. So as you can see that the right side of the whole array is always filled with the largest element, and that's why the sorting comes in clutch in over here, because then we do not need to run the loop whole again and again to just to see if we are able to include that number or not. If we are not able to include that, we again need to run the whole iteration to find the previous consecutive largest number that has arrived in the nums array. So that all hustle has been cleared off, because we just sorted the array, and then we'll do the iteration. We'll start the iteration from the back of the array, because we know that the back of the array consists of the largest elements that are included inside the nums array. That's why coming to my code, as you can see that I first sorted the array using the arrays dot sort, and the nums is the name of the input array. After that, I created a pre-long data type array over here with of length nums dot length. Now I use this pre over here, pre-array of long data type, to store all the sum of the current to store the prefix sum at each and every element. Now how the prefix sum is working, as first let me show you the loop that is calculating the whole prefix array. Now first I included the first element, and I equated the first element and then element in the nums and pre as equal, because so consider this second line as the array pre-array. Now, why did I do that? Now, pre-sum means that the addition of the current element with the summation of the rest of the element. Now if we go to the first element, we know that the first element is the first element itself, but there isn't any data preceding it or previous to it, so there is nothing to add. That's why in the first slide, I simply equated the first element of the pre with equal to the first element of the num, because there is nothing to add. And that's why as you can see that I have initiated the for loop using the index, first one index over here, not zero, and one index represents the second element. So that's why because at the second element we have an element to add to the current element. So if we go to the command, it says that a the element at ith index inside the P should be equal to the pre-sum from the I minus one index plus the the element at the current index inside the nums array. Now, how is this working? Now, if we come to the second element, it means that I will add the pre-sum of the previous element, because we know that the each of the if we check the pre-sum of the preceding elements, it is always equal to the summation of the all the previous elements. That's why we are adding it to the current element to get the pre-sum till the current index. So if we do that according to that logic, the pre-sum of the previous index is 1, and if we add the current element inside the num, so the pre-sum would be equal to 2 at the current index. Now we go to the next iteration. Now the I would be equal to 2. So if at the second index, we will first put the pre-sum of the previous element inside the pre-sum array or pre-array. So as we know that the pre-array, the previous element of the current element inside the pre-array contains the summation of the all the previous elements. So as you know that 2 is the summation for 1 and 1 over here. So that's why first we will plus 2. Now we will add the current element from the nums array, which is 2. So 2 plus 2 at the current index inside the pre-array would be equal to 4. Now we go to the index 3, and now index 3, how would the calculation occur? It would first take the pre-sum from the previous element. Now as we know, as I am telling keep again and again, the previous element, so the element previous to the current element inside the pre-array contains the summation for the whole each and every previous element that we have iterated over in the past iterations. So if we check the summation in the previous element, if we check the previous element, it is 4, and we can also verify that 1 plus 1 plus 2 is 4 till the current index. So that's why we are taking this 4 from the pre-array and adding it to the current element that we are iterating on from the nums array. So 4 plus 3 is 7. Similarly, we will go to 5. So 5, we'll go to now the index is 0, 1, 2, 3, 4. So at the index 5, we will add 7 plus 5, which is 12. Now at this index, as you can see that it is 0, 1, 2, 3, 4, 5 at the fifth index. We will add 12 plus 12, which is 24. And then finally, we will get 75 as the sum. Now, now observe that as you can see that the corresponding elements of the num array and the pre-array represents the sum of all the elements that I've iterated on from the iterated on including the previous iterations and the current iteration. So if we check at the 12 element inside the num and we compare it with the current element inside the pre, as you can see that it is the summation of all the element, all the previous element till the point I am currently iterated over. I am on. So using the pre-array, we will find out the polygon with the largest side. Now, how did I achieve that? I started the iteration from the back of my array, from the back of my sorted array. So as you can see that I first iterated on 50. Now the first iteration would be on 50. Just a second, 50. So I is currently over here. This is the position of I. Now what I did is that I compared it with the previous sum of the I compared it from the previous element inside the pre-array in comparison to current array. Now, what I mean from that is that I compared the element that is inside, that is at the current index, which is I, inside the nums array with the element that is currently available at the I minus 1 index inside the pre-array. So at I minus 1, what would be the element? It would be 24 over here. Now we know that the 24 is the summation of all the elements that we calculated previously. So we will compare the current nums array with the I minus 1 index of the previous pre-array. Now, as you can see that the 50 is less than 24. So it means that we cannot include 50 because 24 is the summation of all the smaller lengths that are available inside the nums array. So we will negate the 50 and according to the pre for loop, as I told you, it is a byte iteration. So the updation command would be minus minus over here. Now again, I forgot to mention the condition for the for loop to be running. It is that I should be always greater than equal to 2. Now, why is that? We know that the minimum number of sides needed to make a polygon is 3, and a polygon cannot never be formed with number of sides less than 3. So to keeping that in mind, I simply wrote the condition that I should be equal greater than equal to 2. Now 2 is over here represents the index of the third element inside the nums array. Now, if that condition as well fails, if the third element, the third side inside the num array cannot be added, then how number, as we know that the iteration would start from I from the back of the array, and if we reach to the third element, and even the third element cannot be added to the array, it means that only two sides are left, and we know that this we cannot make a polygon with the use of only two sides. So that's why we'll in the end we will do minus one, and we'll come to that as well. Now again, the iteration of I would be minus minus because as we know the updation command in the for loop and it is a backward iterating for loop is minus minus. So now I would be iterating over 12. Now I is currently at 12. Now again the comparison would take place. Now I the element at the ith index in the nums now currently represents the largest possible side that we can possibly include in our polygon because we have negated 50 because it cannot be included. So 12 can possibly included inside the our whole polygon, but it needs to satisfy the most crucial condition, which is it should be less than the summation of the all the rest of the sides. Now, how are we getting the summation of all the rest of the sides is by comparing with it with the I minus 1 element at the pre-array. So the at the I minus 1 index, the pre-array contains 12 as its answer, and 12 is the summation of all the rest, all the rest of the sides. So 12 is equal to 12 and it is not strictly greater. So as we know that 12 is not strictly greater than 12, it means that 12 cannot be included as well. It does not satisfy this condition over here, which is nums at I is not less than the pre element, so is not equal to the element available inside the pre array at I minus 1 index. So again, the loop would go to the next I value, which is I minus minus. So now I would represent 5. Okay, now coming to the 5, it would again check for the condition if condition if the current element inside the nums array is less than the element at the I minus 1 index inside the pre array. And as you know that the I minus 1 index inside the pre array represents 7 element, 7 number, and the 7 is strictly greater than the current number inside the nums array. It means that we are able to include 5 inside a polygon, which means that we have found a polygon with the most number of sides. And also I forgot to mention, for our perimeter to be the maximum, we need to include as much sides we can possibly include in a polygon. So if we found our first side that we can be included with the help of the back iteration, it means that the rest of the elements would automatically will be included inside a polygon. Hence the largest perimeter would be equal to the pre-sum, would be equal to the number available at the current index inside the pre-sum. Now, because the pre-sum includes the summation of the current side plus the summation of the rest of the sides that are smaller than the largest side inside the polygon. So then we will simply return the current element inside the pre-array, which, as you can see, that it is return long sorry, the element at ith index inside the pre if the condition is satisfied. Now, if we are not able to find, which means that if I reaches to, for example, if I is able to reach the index 2, now 0 1 2, it would be 2 over here. Now if it reaches the third element inside the nums array, and not even once the return statement was triggered, it means that we are not able to form any polygon using the elements that are available inside the nums array. So that's why it would simply the loop would break, because I can only go till I can only be either greater than or equal to 2, and if the third element is cannot be added to the polygon as well, then I would be negated, and now the current I value would be 1, which does not satisfy the loop condition. It means that the loop would break, and it would then execute this command, which is return -1, which signifies that we are not able to form any polygon with the help of the use of elements that are currently present inside the nums array. So that's how the code is working. Now I'm simply running the code to test all the test cases. As you can see that my all the 3 test cases have been passed. Now I'm simply submitting the code to further test its viability. As you can see that my code has been successfully submitted. Now coming to the time complexity of this whole code. Now let's first check for the for loop. Now how both of the for loops are working. The first for loop would always iterate to till the whole length of the array, which means that the time complexity for the first for loop would be O of n, where the n represents the iteration for the number of length, sorry, where the n represents the length of the whole array. But the for loop, there are different cases for the for loop, but the worst case would be it would always iterate till n minus 2, because as you can know that we are back iterating from the back of the array, and it would only reach till 2 over here. So it means that the worst case would be the n minus 2. But we should not forget about the sorting function that we applied at the starting of the code, and the time complexity for the arrays.sort nums is always n log n, and that's why this sorting algorithm or the sorting method that I'm using over here would dominate the overall time complexity of the whole code. So the time complexity of this whole code would be equal to n log n, just because of this sorting method that I'm using over here. So that's all for today's trick question. Thank you for watching.